In this chapter or unit, we're going to be looking at a few things. We're going to start off with the states of matter. We're going to look at a few gas laws, and then we'll finish up this unit with some phase changes. So to start off, we're going to look at some states of matter. There are three that are very common, and that would be solid, liquid, or gas. And all materials can be placed into one of these categories, and it really depends on their shape and their volume. So let's look at each one, and let's look at how the shape and the volume changes so that you could decide if something's a solid, liquid, or a gas. This would be a picture of a solid. Solids have a definite shape and a definite volume. That means that it does not change. The shape is fixed. This is kind of a cube-shaped crystal, and it has a definite volume. It takes up a certain amount of space. You can't squeeze it into a smaller container. It's rather stiff material normally. Most solids have an orderly arrangement of particles, so if these were atoms, they are arranged in a very specific pattern. Not all of them are cube-shaped, but all crystals have some type of a pattern to them. Then you have liquids. Liquids have a definite volume, meaning that the volume cannot change, but their shape can. So you can take a liquid, water, milk, whatever, and you can move it from container to container, and obviously the shape of the liquid takes the shape of whatever container it is in. And it can be poured from one to another, so it flows. But liquids cannot change their volume. If you were to take a gallon jug and try to take all of that water that's in a gallon and put it into 2 liters, it wouldn't fit. So it has a specific volume. Liquids, if you look at their particles, there is some space. Some of them have a lot of space in between them. Some of them just have a little bit of space. They're not nearly as orderly as that picture of the solids that I showed you a few moments ago. And so because of that, that allows them to kind of move around on top of each other and so on, and give them that ability to be able to flow and move and take the shape of their container. If we look at gases, gases don't have a definite shape and they do not have a definite volume. So their volume can change and their shape can change. Notice that here the particles much further apart, and all the particles are constantly moving. So they don't stay still like solid particles do. Gases do take the shape and the volume of their container. The atoms are not arranged in a very neat or orderly pattern, or any pattern at all. And there's a lot of space between the atoms. So gases have the most amount of space, liquids have the kind of the middle amount, and then solids have the least amount of space between their atoms. You can compress a solid, you cannot compress a solid into a smaller space, but you can a gas. That's why we have like oxygen tanks and things. We can take a gas, we can put it into a tank. You can take the air and fill up your car tires. So you can take gas and put it into smaller containers. So if you look at this picture, this kind of summarizes everything that I just mentioned. Solids hold their shape and they hold their volume. Liquids, their shape can change, but their volume stays constant. Gases, their shape fits their container and the volume fits the container. There's 2 other states of matter I want to mention, and these not as commonly talked about, but actually plasma makes up 99% of our universe, and that is because that is what the sun is made out of. This only exists at very high temperatures, and the sun and the stars kind of fit into this category. They're not really solids, liquids, or gases, they're plasma. And then the last one is called BEC, which stands for Bose-Einstein condensate, and this happens at very low temperatures. So plasma and BEC are kind of opposite each other. So we're talking negative 273 degrees Celsius. Just so that you can compare, water freezes at 0. So you're talking about very, very cold temperatures in order for this to happen. And because it's so cold, the atoms, there's multiple atoms, but they behave as one single particle. So they kind of all move the same. They follow each other. So it really acts like one atom, even though there are multiple atoms. And that's where we'll stop with this video on solids, liquids, gases, and the different states of matter.